All right, kiddos, let's look at these notes on understanding the parts of chemical equations. And again, a lot of this is going to be review from what we've talked about before. So a chemical equation is the symbolic representation, which means that it's written in symbols instead of words. So the symbolic representation of a chemical reaction where the reactants are on the left side and the product is on the right side. Of the equation. All right, and then over here it wants us to just remind ourselves that a subscript is the little number, and that tells us the number of atoms, so it's just the letter it's next to. And the coefficient is the big number, and that tells us the number of molecules. Okay, so when we're talking about reactants are what you start with. And I like to think of it as your ingredients. And the products is what you make or what you end with. And this arrow in the middle has a fancy name, and we use the word yields. And that is just a fancy way of saying that it makes something or it changes into something. Okay? So if we look at this example over here, we have our reactants on the left, and we have our products on the right. And it wants us to stop and count our atoms, just like we've been doing. Only now we're going to count everything on the reactants side. So if we look over here, carbon. Carbon has no subscript, but there are 6 of those molecules, so I have 6 carbon atoms. Hydrogen, I have 2. So 2 times that 6 coefficient means that for hydrogen I have 12. For oxygen, here I have 2 times 6, which is 12. And over here I have just 1 times 6, so that's 6 plus the original 12. So for oxygen I have 18 on the left.
Well, I mean, like,
Over here on the right now, in a minute, Tommy, okay?
okay.
Over here on the right, for my carbon, I have 6, no coefficients. Hydrogen, I have 12. And oxygen, I have 6 here. Plus here, I have 2 times 6, which is 12. So 6 plus 12 is 18. Now, if I look at what I have done for my math, my products, I have 6, 12, and 18 on the reactant side. My products, I have 6, 12, and 18. When I have a chemical equation and it's written out properly, it should have the same number on each side. And that is what we call it when we say balanced. So balanced is the same number of atoms on both sides. And reactants have to be balanced because of something called the law of conservation. Conservation means saving something of mass. And the law of conservation of mass says that matter cannot be created or destroyed. That means that if I want to make water, H2O, I have to start out with hydrogen and oxygen atoms from somewhere. I can't just make them appear out of thin air. That also means that when I am turning that water into something else, the hydrogen and oxygen atoms have to go out into something. They can't just disappear. We're going to talk more about this law of conservation of mass in the next set of notes. So then last but not least, these types of reactions over here, and we're going to talk about this in some notes next week, but I just want to make sure that we have it all written down here. We don't want to leave anything blank. So the first type of reaction that we're going to learn about later on is a single replacement. We can also have a double replacement. We can have synthesis. Synthesis is a fancy word that means putting together or a combination. We can have decomposition, like you learned about in ecosystems. Decomposition is when something is broken apart or down into smaller pieces. And we can also have combustion when things burn. And we're going to learn about all of those next week.